Okay, so we are doing notes number 1. We're starting unit number 8. This is also going to go with chapter 8 in your book, so you know that it's there, or where it is in the book. But we are going to kind of go through our first set of notes today on a video. This should be pretty simple. This is all review stuff that you've learned before, so hopefully we'll get through this pretty quick. Go along with the notes. There'll be a couple questions along the way to answer during the video. Finish this, and then you get your 10 homework points just for completion of it. Okay. And then there's a homework number 1 after this that you can start working on, or if you want to save it until after you finish your test and all that, that's perfectly fine too. But we'll do questions over homework 1 the next time we have class, and we'll do notes 2 then as well. Okay, so basically all we're going to go over today is remembering how to simplify radicals, and then also going through the Pythagorean theorem. So a couple rules that we learned about simplifying radicals in both Algebra 1 and Algebra 2. The first thing is we never want to leave a perfect square factor other than 1 underneath the radical sign. So for example, if we're doing like the square root of 20, that can be rewritten as the square root of 4 times the square root of 5. That 4 is a perfect square, right? So we take the square root of that 4 and we get a 2, and then we still have a 5 inside the radical, but we took out that perfect square factor. Another one is we never want to leave a fraction under a radical sign. So if I had something like the square root of 5/4, anytime you see a fraction under a radical, remember you can split that and make that the radical of 5, or the square root of 5 over square root of 4. And then we know what the square root of 4 is, so that becomes radical 5 over 2. We don't want to leave that a fraction. We want to split those and do each one individually. And then the last thing, we don't want to leave a radical in the denominator of a fraction. If you remember, this is called rationalizing a denominator. So if I have something like 3 over the square root of 2, we rationalize that by multiplying by radical 2 over radical 2. And then we multiply across the top, we get 3 radical 2. And when I do radical 2 times radical 2, that's radical 4, which is just 2. Right? Those are kind of our 3 rules when you're trying to simplify radicals. There's other stuff too, but those are the 3 basic ones that lead you to everything. So a couple more examples here just to make sure we remember how to do these. So 75, we're either looking for a perfect square that we can take out of 75, or some of you may have learned to do it with like a factor tree that way, right? So I recognize like, hey, 75, I can break that down into radical 25 times radical 3, and then the square root of 25 is 5, and I keep my radical 3. If you can't come up with the perfect square factor, if it's a bigger number, and even on bigger numbers, I'll do it this way. Remember, you can do a factor tree of 75, and I could say, well, 75 is 5 times 15, and then 15 is 5 and 3. I look for, I've got this pair of 5s, which means a 5 gets to come out. The 3 is left by itself, so it has to stay in, right? So either way, we get an answer of 5 radical 3 for the simplified version of radical 75. The next one, we've got the square root of 9/12. Again, we can break this into 2 parts of a fraction, but I always tell everybody, make sure you simplify a fraction inside of a radical first before you break it apart. Because if I simplify this one first, 9 and 12 are both divisible by 3. So I'm going to rewrite that as 3 over 4 inside that radical. And then when I break it apart, I get radical 3 over radical 4. And we know the square root of 4 is 2. So that's radical 3 over 2. Right? It's always going to be simpler if you reduce the fraction before you break it apart, or break it into 2 different radicals. The next one is very similar to what we did before. We've got a radical on the bottom, right? I cannot this time just divide 12 and 3, remember, because 12 is outside the radical, 3 is inside the radical, so you can't just divide that and get 4. That doesn't work. Instead, we want to get rid of the radical on the bottom, so we're going to multiply by radical 3 over radical 3, because that way in the bottom we'll get the square root of 9, which is just 3. So then we end up with 12 radical 3 over just 3. Now, because the 12 and the 3 on the bottom are both outside the radical, we can divide those. So 12 divided by 3 gives us 4 radical 3. So the next one is 8 over 2 radical 2. You could go about this a couple different ways. You might want to just go ahead and say, hey, there's a radical on the bottom, so I'm going to rationalize. Remember, you only are worried about the radical on the bottom, so I don't have to multiply by 2 radical 2. I can just multiply this by radical 2 over radical 2, which will give us 8 radical 2 over the 2 is still on the bottom, but then radical 2 times radical 2 would give us just another 2. So we end up with 8 radical 2 over 4, and then we can divide. 8 divided by 4 is 2 radical 2. Now, you could have instead, if you wanted to, you could divide the 8 and the 2 first, which would give you 4 over radical 2, and then you can rationalize that way, and you'll still end up with that same 2 radical 2. So either way works there. Whichever you decide to do is perfectly fine. Okay, then just kind of reviewing a couple other operations with radicals because we'll be dealing with them in this chapter. If you've got radical 20 times radical 2, if you're multiplying two radicals, if they're both inside the radical, you can multiply those numbers. So this would give us radical 40, and then we can simplify that. That's a 4 and a 10. That's a 2 and a 2, and the 10 is a 2 and a 5. So we've got a pair of 2's, so 2 goes on the outside. The 2 and the 5, we multiply those back together, and that has to stay on the inside. So 2 radical 10. Sometimes it works out where you can simplify these first. So I could look at the 2 here this way and simplify this one to 2 radical 5 times radical 2. And then we still get 2 radical 10. Either of those are fine. Sometimes they won't simplify and you have to simplify after you multiply. So I tend to do it that way, but either way works there. Okay, then if we've got numbers on the outside, like in B, you can multiply outside numbers, multiply inside numbers with radicals. So I can do the 3 times 8, but just remember, this is a whole number and this is a whole number. So don't do any like weird distributing. I've seen that before. We're not doing anything across addition here. We're just multiplying two numbers. So we multiply the rational parts. 3 times 8 gives us 24. Then we multiply the irrational parts, or the radicals, and we get radical 12. And then again, we want to simplify from there. 12 breaks down to 4 and 3. So there's our perfect square, right? That's a 2 and a 2. So that means I've got 24 times 2 radical 3, which is 48 radical 3. Okay. All right, then finally adding and subtracting with radicals. Remember, in order to add and subtract with radicals, it's kind of like adding like terms. So right now it's something like 3x plus 5y. I can't add those together. These are two different numbers inside the radical. We want something instead where we have like 3x plus 2x. Then I can add those coefficients together. We can do that by simplifying each of our radicals sometimes. So if I break down the 18, 9 and 2, that's a 3 and 3. So this is 3 radical 2. 50 I can break down to 25 and 2. That's a 5 and a 5. So then we get 5 radical 2. Now that they both have a radical 2, I can add together the coefficients. So we end up with 3 plus 5, which is 8 radical 2. Okay. Quick little review there of some stuff with radicals that we've done in the last 2 years. So simplifying, breaking them down with either a factor tree or finding perfect squares, rationalizing denominators you've done before, multiplying, and then adding with radicals. I realize that some of you have calculators that do this for you. We won't be using those calculators on this test. You want to make sure that you know how to do this stuff by hand. You'll need to show your work on this stuff. Okay. All right. The second thing we're going to review today that you've probably seen before, maybe in middle school, is the Pythagorean theorem. Pythagorean theorem says that in a right triangle, the square of the hypotenuse is equal to the sum of the... This one big key word here, my pen is stuck. Come on, there it goes. Is that it has to be in a right triangle, right? This only works for right triangles. So this is where if we've got a right triangle, a couple of vocab things to remember. Right triangle means we have a right angle. The legs are the two sides that make the right angle. We usually call those A and B for Pythagorean theorem. And then the side opposite the right angle is the hypotenuse. So then our Pythagorean theorem says that if I square the two legs and add them together, then I get the square of the hypotenuse, or a squared plus b squared equals c squared. Okay, we use that to find missing lengths of right triangles. For example, if I have this right triangle and I want to solve for a, right, I could call that side A, my other leg is B, and my hypotenuse is C. So in this case, I'd have a squared plus my b is 4 squared should equal c, which is 6 squared. So then we get a squared plus 16 equals 36. That means a squared has to equal 20 if I subtract over the 16. To solve for that, I can take the square root of both sides. So I'll get a equals, if I'm taking a square root, don't forget you need the plus or minus. Maybe radical 20. I want to make sure I simplify my radical if I can. That one's got a square root or a perfect square of 4 in there, so we can take out a 2. So our a would equal plus or minus, because we don't know if it's a positive or negative, 2 radical 5. However, we are solving for the length of the side of a triangle, right? We don't usually have negative lengths of a side of a triangle. So in this case, it would have to be the positive answer, 2 radical 5. Okay, all right, let's try another one here. Same idea this time. We've got a that we're looking for. This time, though, this a, that's like our c, that's our hypotenuse, right? These two are our legs. There's our A and our B for our legs, right? So we're going to do 2 squared plus 3 squared should equal the A squared. And when I say A, I mean the variable A. That's like our hypotenuse. So we get 4 plus 9 equals A squared. 4 plus 9 is 13. So then to get a, we're going to take the square root of each side. So we get plus or minus radical 13. 13 is prime, so I can't simplify that. And again, we're looking for the length of the side of a triangle. So the positive radical 13 is the only one that makes sense. All right, the next one. Now this time, A is both of our legs this time. So this is an isosceles right triangle. Our two legs are equal lengths. And then this one over here, this is our hypotenuse or our C. So we're going to do A squared plus A squared. Those are our two legs. Should equal C squared, which is our hypotenuse. So 4 squared. That gives us 2A squared equals 4 squared is 16. Divide both sides by 2, we get A squared equals 8. Take the square root of each side. That gives us A is plus or minus radical 8. We can simplify that 8. That's a 2 and a 4. So we got a pair of 2's. So our A would equal the positive 2 radical 2. Okay. Both sides of that one. So that's kind of the basics of our Pythagorean theorem. Hopefully you remember those. You probably did some simple ones in elementary school, or not elementary, sorry, middle school. But a lot of times in middle school, you don't deal with the radicals in your answers. You typically do either decimals or you're given ones that work out nicely with integers rather than irrational numbers. Okay, a few more examples here. For number 4, again, the same thing. Always identify your hypotenuse so you know which one's which. This one here is our hypotenuse, remember, because it's opposite the right angle. So this is actually our C. And then these are our A and our B. There's our legs, right? Be careful here when you square the A minus 1. Parentheses are going to be important there. So we've got A minus 1. We're going to square that one. Plus our other leg, which is 5 squared. Should equal our hypotenuse, which is A squared. When I square A minus 1, remember you want to write it out twice. A minus 1 times A minus 1. That's going to give us A squared minus a and minus a, so minus 2a, and then -1 times -1 is +1, plus our 5 squared is 25 equals a squared. I can combine my like terms there, so a squared minus 2a plus 26 equals a squared. To get my a squareds together, if I subtract that over here, they're just going to go away, right? So then we end up with just -2a plus 26 would equal 0 because that a squared went away. And then if we finish solving, move the 26 over, divide by -2, we get a equals 13. Okay. All right, next one. Sometimes we can have other shapes that we can find right triangles in and use those to help us. So we're looking for x over here this time. This time we've got a trapezoid, it looks like, or a quadrilateral. But what we can do here is we can drop in an extra side here, or an extra line. And if I drop that in, that's also a right angle, right? On both sides. So now I've got this lovely right triangle over here that we can use the Pythagorean theorem on. And if that one's a right angle, then this one also has to be for this four-sided shape here. And that's a rectangle, right? So I can use that rectangle because I know it's a rectangle, and I know I've got 5 and 8. That means that this side also has to be 8. And if this piece here is 5 and this whole piece down here is 11, well, if I take off the part that is 5 there, then that means this piece has to be 6. So now I've got two sides of that right triangle, right? So now we've got a right triangle where we've got 8 and 6, and we're looking for x. So we can do 8 squared plus 6 squared, because those are the two legs, equals x squared. That's our hypotenuse. So 64 plus 36 equals x squared. Oh, that gives us what, 100 equals x squared. So our x would be plus or minus 10, but because we're doing a length of a triangle, 10 is the one that makes sense there. Oops, fix that circle. Okay, there's our x. So look for right triangles that you can create in other shapes. That sometimes helps if you're stuck with a different shape. All right, and then our last example here, it says the perimeter of a rhombus is 68 centimeters. One diagonal has a length of 16 centimeters. How long is the other diagonal? Okay, so we've got a rhombus, right? A rhombus is a parallelogram. And if you remember your properties of a rhombus means all four sides are the same length, right? So if the perimeter is 68 centimeters, then that means a side would be 68, divided by 4, because all four sides are the same, right? 68 divided by 4, that gives us 17. So all four of these sides are 17. And there's one thing we've got. Then it says if we put in one diagonal, it has a length of 16 centimeters. So I can draw in one of my diagonals, and it wants to find out what's the length of the other diagonal, right? Now in a rhombus, the diagonals are different lengths, so they're not the same length in a rhombus. They're only the same if it's in a rectangle or a square. But we do know in all parallelograms that the diagonals bisect each other. So this and this have to be the same length, right? And then this one and this one have to be the same length. So one of the diagonals is 16. If I split that in half, that means that's 8 and that's 8. And we're looking for this other side over here. Okay. The other thing we know about a rhombus is that our diagonals intersect at a right angle. Hey, look at that. It's a right triangle. So now we've got this right triangle we can kind of pull out here. Here's 17. This is 8, and we're looking for x. And there's our right angle, right? So we do our two legs added together. So 8 squared plus x squared is the other leg. will equal 17 squared. So 64 plus x squared equals 17 squared is 289. I should probably double check that, but I'm pretty sure that's right. Then we get x squared equals 289 minus 64. Oh, it's late. I can do that in my head, can't I? Minus 60 is 20. Is it 225? I'm going to double check my math just to make sure. Yeah, 225. Good job, Miss Mac. Okay, then we take the square root of each side. And of course, we do plus or minus, but we're looking for the length of a segment. So the positive makes sense. So x equals 15. Now be careful though, because this question said, how long is the other diagonal? X, remember, is only half of that other diagonal. So if x is 15, then that means the diagonal, would be twice that. So it would be 30 centimeters. Okay. So you're going to see some of these kind of on your homework. If you have to look back at old notes, if it talks about a rhombus or a rectangle, diagonals and such, look back at your older notes to remember those properties of parallelograms if that helps, or other quadrilaterals. Okay, but that's basically it for today. Pretty short, radicals and Pythagorean theorem. Hopefully it's a lot of review for you, and this homework is pretty quick, but that's all we're going to do for today.